All right, I think we'll make a start. So yeah, thanks for joining today's session. So my name's Dick Harrop. I'm one of the senior research engineers at GeoSLAM, and I was one of the principal team members involved in the Vision development program. This webinar really is for users who have a Vision already, just to try and talk through the process of taking data, making sure you're getting the best data from the camera, working through some of the processing steps, maybe explaining in a bit more detail how I've written the workflows and how we envisage the workflows to be used. As I don't think none of these workflows are set in stone. We're always taking feedback. If you want more options or less options on them, then yeah, we can put that in. So what we'll cover today, as I say, we'll cover ZEB Vision. I think most people know about the camera. This is really more of a technical webinar. So we'll talk about some capture techniques. I say at the moment, all those people receiving your cameras, we're asking you to take some data so we can do this system calibration. So talk a bit more about some of the environments where we need for those captures. I think data download, everyone's reasonably happy with it at the minute. That seems very okay. And then, yeah, as I say, we'll go through the Connect workflows and then some Q&A. ZEB Vision, as we know, it's a 4K panoramic sensor. That was the basis of the development program that customers and dealers we've been asking for panoramic imagery to go with the horizon. So that's what we produce, a small handheld system. So then when you receive your Vision camera, clearly there's some calibrating needs to be done to the camera. The two lenses are circular fisheyes, so we obviously need to model those, to look at the distortion model on those, and that's what we're doing here at GeoSLAM. We'll work all that out so we can make that correction, and obviously then look at the stitching between the front and the back to give us this full equirectangular spherical panorama. So all that data is stored in a single calibration file, which is in a JSON format, human readable JSON format, and these are stored on the camera. At the moment, every time we chip a camera, you'll receive on that drive this cameracal.json file with these parameters in them. The one thing we can't do, obviously, is then be able to work out the offsets between the horizon sensor and the camera sensor. And that's why we've been asking customers who upgrade to take some data for us, and then we can work out the rotations between horizon datum and camera datum. Again, the parameters for that, there'll be a simple XYZ offset for the lever arms, and then a roll pitch heading or roll pitch yaw between the two sensors. And again, they'll get stored in this camera cal file, and we'll send that back to you. And then from there, you can start taking project data, demo data, and everything should be good. So some general techniques for taking data with Vision. It is designed that you can capture whilst walking. You don't need to to stop and capture imagery. It's continuously recording at 1 frame a second, 1 panorama per second. But clearly, what we're trying to do is make that capture as smooth as possible. We do a lot of work here on using the backpack, but we've also obviously done a lot of indoor capture testing in handheld mode. But I think the specific thing we're looking for is how smooth that data is and the data capture. Like any camera, if you move it around too much when you're taking an image, you're going to get blurred images. So what we're trying to do is just walk nice and steadily. Typically, I would say we walk slower than we would for a normal horizon capture. You know, markedly slower. We want to avoid sharp turns or sharp movements of the camera. Again, all these things will lead to either a blurring of an image. There may be some stitching errors because of the angular motion between the time, the time between the front and rear cameras firing. And of course, the more we move around, the more misalignment we may see between the imagery and the horizon data. And we can see that quite clearly as an offset between the two, and that generally is just because of a high angular rates of capture. So smooth, steady, slow wins the race when taking data with horizon and vision. So on the camera, we do employ automatic exposure algorithm rather than setting a defined exposure and gain for the camera. This means we can at least, we've tried to map those parameters such that it will give us good results over a wide range of lighting. Clearly very dark and very bright, we may have to look again at some of the parameters. But for the minute, we've tried to set the camera up so it works in the majority of light conditions to give you the best data. If you're going to go from indoors to outdoors, very dark to very light, again, I'd probably suggest just standing still for a few seconds just to give the auto exposure settings a couple of seconds just to catch up with itself and realign the gain and brightness settings. At the moment, on these cameras, the internal storage is 6 gigabytes. Should give you around 50 minutes of capture. So, that's something to be aware of when you're in the field all day, that, you will need a laptop or some device just to download over the Ethernet port. And then remember to obviously delete them off the camera once you've downloaded them. So what are we really looking for in this calibration capture? What we're trying to do, in all circumstances for this is just all, we're trying to identify something within the point cloud and identify the same object within the imagery. Then we can say this point in this cloud is this point in the imagery, this point in the cloud, this point in the imagery. And generally what we're looking for, we use the intensity field when we're looking at the scan data. We're looking at points on the ground. So white lines are very useful. You can see in this example, guys in Italy found a nice pedestrian crossing, any road signs, something we can easily pick out, like a storm drain cover, drain coverage, cracks, in pavement are quite good. Something it's just something we can easily identify. You can go, right, that is definitely So I can see that as an object in the imagery and in the scan data. And you know, we try and get at least three good ground marks. What we're trying to do, obviously, is then, you know, because we're really minimizing those rotation angles, what we're trying to do is in the image have a good distribution of points like you would for any georeferencing. You want four, you know, preferably four good well-spaced points. So then we're looking at points that we try and use at height to give us a different capture in a different part of the lens. So again, corners of buildings we can use. Road signs are okay. Then, you know, they're not generally that high. Typical, you know, 2-3 meters. Lampposts are very good. You know, something with 5, 6, 10 meters of height. Then we're getting a good coverage map of points all the way across the lenses, and that's going to help, you know, minimize the rotations between the two. Clearly, what we'd like, we don't want objects too close. We certainly don't want objects, you know, within a meter or so of the camera, start to run into parallax issues. So, you know, 5 meters either side. We obviously want to be able to identify them very precisely in the imagery and in the point cloud. So again, we don't want to go 30-40 meters away from the camera where, you know, the objects start to pixelate. So we'll try and keep these objects within 20 meters of the camera. Generally, you know, we don't need a lot of data. Clearly, the capture time is really more defined about what objects you think we can identify in that image. You know, again, this was just a 5 minute walk rather. Not 100% ideal. It's quite closed environment, very narrow street, difficult to get high points, but, you know, clearly we can get, you know, we can do a calibration on this kind of data. But yeah, you don't need to, you know, it's not a 20-minute capture. This is just 5 minutes around the office, around the building, and that should be fine. Then download the images, download the .GeoSLAM file from the data logger. Ideally, take a picture of the back of your Vision so we know precisely what serial number we're looking at. Then we can cross-reference the records we have here with the original calibration file we shipped out, just to make sure we've got that right. Then we can process that, usually within 24 hours, get that back to you. Again, another example of a good environment. This is taking out the guys out in China. Again, they're very lucky where they were. They got good road markings, lots of tall buildings. Yeah, nice steady walk, capture, no sudden movements, no jerk movements in the capture area. So they were able to give them a really good calibration. This one, some of the guys over in North America, not such a feature-rich environment. You see there is a building, although it's a single story, quite low. No real markings in the road. There are some street lights, but you can see, unfortunately, when we did the capture, or the person who did the capture didn't really actually go past it, only towards it. So it's, you know, it's not really usable that we could use any of these. So we have street lights here we could have used, you know, if they'd have, you know, walked up and then come back. But unfortunately, it didn't quite make it that far. And again, there was lots of movements and jerkiness in the camera. Just didn't really give us the best possible calibration that we could for the environment. You can see in this image, it's quite open. You can see an effect of moving the scanner around quite a lot. You start to see these kind of stitching errors, and that's purely down to how the we're taking and calibrating the data. I think I do have that one as an example. So again, if we look how the horizon's being held, it's kind of going left to right, right to left. It's kind of moving it up and then down, and up and down quite inconsistently. Well, what we're looking for is, just a smooth transition through the environment. We don't need to point it at things generally. The horizon will capture tall buildings. We've got a 360 camera. So just small tweaks in how we capture data now with vision and horizon will give us our best result. So I say once you've taken the data, downloaded the imagery, downloaded the .GeoSLAM file, hopefully taken a picture of the serial number, sent that off to us, we'll do the calibration and update this calibration file. So on the calibration file, you would generally, it is human readable, as I say. There are 4 main sections. You can open them, have a look. First section really is just an information section that we put in when we create the file. When it was created, we can put some notes in there. Obviously, we put serial number of the camera and the horizon if we've got it. And then, moving forward, we know if there's any trouble that gets sent to us, then we can look back through our records and see how the camera was performing in the past. As I said, second section is really the section that will our intrinsic calibration that we do in-house. Most of these are the lens distortion model, and then some of the excuse me, the rotation angles, how we move the images around to make them make the panorama, some crop areas at the bottom to remove the black around. You've probably seen when you've looked at your raw images, it is a circular fisheye lens, so there is a black surround to the image that we need to crop out and get rid of before we do the stitching. So all this information is calculated by us here at GeoSLAM. I wouldn't recommend altering any of that. I really wouldn't. That would be problematic, I think, if you started playing around with those numbers. But that's what that section 2 in the file is there for. This section 3, although it does say section 2 for some reason, this is the section that will calculate from the calibration data that you're going to send us. Clearly the offsets are very well fixed. It's going to be screwed on the back. We know it's the camera is 0.35 centimeters or 3.5 centimeters in front of the ZEB datum and 20 centimeters higher, and obviously it's in line on the y-axis. Roll pitch and heading, that's the rotation between the rotation angles of the horizon and the camera, and that's what we're trying to calculate, and that'll give us this nice alignment between the scan data and the imagery, and obviously is important when we start to colorize. We do record those in degrees and in the quaternions. All the software really uses the quaternions. We just wrote roll pitch heading in degrees for human readability. If you wanted to alter those, you certainly could, but you would need to alter the quaternions if you wanted to see an effect. Again, I probably wouldn't recommend that at this stage. but it's there. If you could play around with the roll if you thought that was slightly off, but then you'd have to recalculate the quaternions. So again, not something we'd recommend. We can certainly, if the system does go out of calibration, if you take the camera off the horizon, or it gets knocked, or you think, you start to see more of a misalignment between your imagery and your scan data, then you could take another calibration capture, send that to us, and we can recalculate these angles for you. And the last section is where we've got some imagery masks that are used by the colorizer. Clearly, it's a handheld system, a pano system. So whilst you're walking, the operator is always going to be in view. We don't want that information to be used in the colorizer. So that's why we've defined a set of masks. So that just tells the colorizer not to use the pixels within this polygon. We've defined polygons or bad polygons to be ignored in handheld mode. Ostensibly what this does is it removes the whole of the rear image in this case. So we would always use the panoramas, but in handheld mode for the colorizer, we ignore those sections which have been stitched in from the rear image. In backpack mode, it's slightly different. The camera is typically a lot higher above your head. There's less of the operator in view. That way, we can include more of the rear sensor. You'll notice in the workflow, there is a third option, which is custom. Again, at the moment, if you weren't using in handheld or backpack, you're using it on a vehicle or some other kind of mount, then we can create a custom mask for you. At the moment, that's something we would do. But if you send us an image, we can create a polygon, add that to your camera control file or camera cal file, and then you just use custom. So that option is in there. But generally, handheld and backpack are where we envisage most users operating the system. So for the processing steps, I think clearly we're using GeoSLAM Connect. We've written a series of workflows which, within 2.1.1, well, in 2, they were tied to the interface. We have released version 2.1.1 recently, in the last week or two. This just has some good improvements for vision. There's a small improvement on the timing. There's obviously improvements to the colorizer and efficiency of the colorizer. So I would recommend that everyone starts to use version 2.1.1. I don't see any reason why you wouldn't upgrade. You'll get a much better result using this version. So the processing steps, clearly we have data download. We'll go through that. Then we've broken those processing steps until we need to process the SLAM, get our point cloud. Then we'll do some stitching of the images. We can do some post-processing exposure if we wanted to. We're going to then create the camera trajectory, and then finally, if we needed to, we can run the colorizer. So there are workflows in Connect that will do this all in one. I would recommend, and the way I run it really is I run those workflows from the ribbon bar. I like to run, see, and then gauge what I've done and have a look at the result. I want to process the SLAM, make sure the SLAM has worked, make sure it's consistent, maybe run some filtering on it, then move on to the stitching, run the stitcher. Maybe I want to test some of the images, then play around with exposure, then quickly run the post creator, and you know, on occasion then I can run the colorizer if I need to. So I definitely recommend running them whilst you're getting used to the, you know, the whole processing workflow and making sure you've got the right parameters. I would say running them individually from the command, from the ribbon bar is what I'd recommend. So data download, at the moment, well, not at the moment, you know, in general, that data download from the camera is via Ethernet port that's on the system, and then the internal memory can be accessed from any FTP interface. All the cameras have a fixed IP address, 169.254.0.206. You can access this from any FTP client. We generally use FileZilla. You can use WinSCP. You can use Windows File Explorer, although generally we've seen Windows is fast indexing, doesn't always show you the latest folder structure, which is why, you know, I'd personally try and use, you know, an FTP client for download. It's much more efficient that way. There is no login details. You can log in using anonymous login type. So just easy access via the 169 address. You'll see on the camera, every time you start and stop a capture, it will automatically create a new project folder. They'll just automatically increment. There's a log file on there where we log, you know, what's going on in the camera, the acquisition time. May help us if anything goes wrong with the camera. At the moment, clearly, we need to store the cal file somewhere because that's quite important. So generally, I create a cal file folder on the camera, and that way I know where it is. I'm not going to lose it anywhere, and that every time I take a capture, I can take a copy of the cal file and put it into the image folder, because that's implicit in how the stitching workflow runs in Connect. So potentially, if the stitching workflow fails for some reason, you know, our first check is, you know, has it found the camera cal file? So process as a whole, hopefully everyone's been using Connect for a while and swapped over from Hub. Creating a new project, again, I would just create a new standard project, pick the default workflow in GeoSLAM. I can then import my .GeoSLAM file, set some output parameters, typically with thin to 10 millimeters, 20 millimeters, and then apply any filtering that, you know, you think you're going to need, or just, you know, typically run the GeoSLAM, and then you may want to tweak your own filters later, again via the ribbon bar. So then we're into our first real vision process, and that's the stitching. If I load this one, so just to step through this one again. So firstly, what we're asking for is the .GeoSLAM. We don't typically use the .GeoSLAM in the stitching workflow. We're just making sure that we're definitely using the right project folder. So we use the .GeoSLAM file just to pick out the project name. And that's why I would just pick from project. Then you need to tell the workflow where you've downloaded your data to. Typically, I've got just a temp drive that I'll download my projects to. Some outdoor data, project 1 from the camera. I've downloaded my imagery. I've ensured I've got my camera cal file in this folder before I start. And then I would pick this from the system. So I would just go through to project 2. Oop. Try that again. D outdoor project. So the next option, excuse me, is then this: choose whether to save additional reference imagery. So what happens with the Stitcher, the Stitcher will automatically, and every time will give you the panoramas, the stitch panoramas. That happens every single time by default within the workflow. What you can additionally choose is, do you also, as well as the panoramas, want to output a rectified, undistorted view from either the forward lens, the reverse lens, or both forward and reverse lenses? If I was to choose both, what I would see in my project folder is I would then get my standard panoramas folder, and then I would additionally have a folder called forward and a folder called rearward, and they would show the unrectified image just from the forward lens. So that's in addition. They're additions to the standard outflow, which is the full stitch panorama. Generally, I don't see that need to output those, but that option is there if we wanted. So the next two sliders, let me adjust the exposure settings for the forward lens and the rear lens. There may be occasions, especially in handheld mode, if people are holding it quite close to themselves, that the rear lens is slightly darker for the same lighting conditions than the forward lens. So you could add a small amount of exposure to the front, just to lighten up, or to the rear, sorry, to lighten up the rear. So when we do the stitching, we get more of an equal exposure. So when we do the stitching, there is some blending that goes on across the seam area to try and match exposures. But if you can see significant exposure differences between the forward and rear lenses, that's why you would use these two. Generally, you can leave them at 0. I wouldn't alter those too much. So they will, as I say, we will rectify the forward, apply any exposure settings here. Then we would rectify the rear lens and apply any exposure at this stage, at that point. Then we would do the stitching. And if after then we still felt that the images were too bright or too dark, then we can define a change of exposure for the whole stitch panorama. So maybe I would want to lighten and darken to get a better match. And then generally, I don't know why you would, but you could then potentially brighten the whole thing afterwards. So the last define every nth. Clearly, if you have a project with 1,000 images and you wanted to just maybe check your exposure settings, you don't want to have to wait for all 1,000 to stitch. So this option, just lets you run every 1st, 5th, 10th, 20 images. So if you had 100 images and put this to 20, then it would output 5 images, which you could check your exposure, do some testing, make sure you're happy with the exposure settings, then change this back to 1, run the whole stitching, and that would then give you the whole 100 images once you've played around with them. Stitching does take a while. It's quite a CPU intensive process. We are working on some optimizations, but for the moment, this process will take some time to run. So what you should see when it is running, you can check in your panoramas folder. You'll see a group of 5 or 10 images. The unrectified versions are brought into this folder. Then you can see them being rectified and joined and then deleted. And that's another good way you can check that the stitch is progressing. Just look in your panoramas folder. Panoramas should be being created. So for this workflow, primarily it's vision stitching, that's what we're doing. But also at this time, we're extracting the times that we took those images. Again, so we output these in the image timings.json file. Again, it's standard JSON human readable. And this will just extract the time the image was taken within system time, and then obviously the name of the JPEG that it was taken. So we do that for all our images. So then we have now a time and attached to that panorama, and we're going to need that information in the next step when we start to create the camera pose, because we're going to need to know exactly when that image was taken. So once this is run, as I say, you should have within your project folder, you will have a copy of your original files that have been copied in. So it's all in one place. You will have an images directory. You will always have panoramas, which, they're just standard JPEGs. If you've chosen additionally to output rear or forwards, again, you would also see those that you can just walk through. Then you'll have this image timing file. So once the stitching is completed, then we can calculate the camera trajectory or the camera pose for each image. Again, within this workflow, we ask to pick the .GeoSLAM file. Again, that's really just to confirm that we have the right data set that we're looking in. So I can choose that one. The trajectory, clearly we need to know where horizon was, so we can then interpolate where the camera is. Typically, I use the GeoSLAM. You can use the traj.txt. They're fairly identical. GeoSLAM has a couple of extra fields in, but generally I just choose that one because it's the first one I come to. Then we need the timing file that we've just created in our stitching. Again, image timings.json. We do need to choose the camera calibration file because that has the rotation angles and the offsets between the camera and the horizon, and that's what we're going to apply in this step. So again, I would choose the camera cal.json. Again, at this point, you don't have to output positions for every image. That option, you can again use every nth. If you thought you had too many images, need to process that many. But this step is very quick, a very quick calculation. So again, when that runs, again, it's very quick. And what this produces then is this GS Vision file. And that now is then the trajectory and orientation of the camera for every image. Again, it's relatively readable. So again, we store for every image the time it was taken, its XYZ position, and again, its orientation, its pose in quaternions and in human readable. So at this point, we can then load a point cloud and enter the bubble view within Connect. We've created our clean point cloud, and now we have positions of where we took each image. So we can choose any of the images, double click on one, and then we enter bubble view. So we can see I can alter the opacity of the point cloud. Maybe set it to elevation. We can move through the point cloud just by clicking on bubble views. That will move us to the next one. Or we can use the panorama details tool. Then we can put in a number we can move to, or use the arrow keys to step, and then we can alter the range for the display of the point cloud. So the last step, if we wanted to, generally sometimes useful to have colored data. We spent quite a lot of time on the colorizer. So this is the last of the vision workflows. This time we do need definitely to input what laser file do we want to extract RGB from the images and apply. We obviously need to tell it, we clearly need to give it the trajectory file, the GS Vision file, so it knows where the images are when they were taken. The calibration file, what we're really using at this point is that if we're going to set a mask, then those mask details are stored within the JSON. So that's why we need to tell it where the project or the camera calibration is to extract those mask details. So the next one is skip the first 10 images. Again, what I would typically do is, what we're really saying is, when I first start my capture, do I want to use this data when it's on the floor, I'm picking it up, I'm just kind of getting my set, I might have getting the backpack on. These images aren't going to give us the best coloring. They're really going to, there's lots of movement, lots of angular movement, lots of sharp turns where I would put backpacks on. So that's why I would then say I would exclude those images from my colorization, because I know they're going to give me a poor result. So I may exclude the first 20 images. Again, at the end of the survey, when I come back to my ground point or my stop and go point, I've got the same thing. I've turned it on. I'm taking the backpack off. Again, I probably don't want, well, I definitely don't want to include those images within my colorizer. So again, that's why I would put in a minus number from the last one, the number of images to ignore. Again, we've added the option that we don't have to use every image for colorization. You know, we are walking quite slowly. We're taking 1 frame a second. You know, we're walking, 1 to 2 meters at most, meters per second at most. So we may not need every image, especially if we're indoor, tight confined space. Maybe we could skip every one and just color every other one. So this option, as we said, defines the masking that we're going to use, really defines how we captured it and what part of that image that I will ask the colorizer to ignore and not utilize. Clearly in handheld mode, as we said, the rear image is going to have the operator in. I want to get rid of the large orange on front of the horizon. I don't want the carpet to be orange. I want the ground to be the ground colored. So it's important that I do set a mask. And as I said before, if you do have a non-standard mount, maybe the car mount, maybe some other kind of mount, or maybe a different kind of backpack, then we can create a custom one for you. Obviously, in this situation, we saw the guys were using handheld. The last big option to choose when using using the colorizer is what part or how we operate the colorizer. So we can view and colorize points either by time or by distance. So what this means is that if we were to choose to colorize those points by time, say, what we do is we take the time that the image was taken, and then take all the points within the point cloud that were captured plus or minus half a second around the image time. And then we color those points with the image, with the data from that single image. So in this way, points are only colorized once. So it's a relatively quick way of colorizing. If I was to use distance-based, this is a much more rigorous way of coloring the data. In this way, what we really do is we take all the points from the whole point cloud that are visible from that one image. So it doesn't matter when they were captured on the trajectory. If I came back and did a loop, I would include those points, where in time method, I've got much less points because I'm only taking the points that were captured around, or plus or minus half a second from when that image was captured. So now you can see that, you know, each point can be colored multiple times. So then we take an average color to apply that to each point. So this is why if we were to run the colorizer, time-based is generally pretty much always a lot quicker, because we're just literally taking image, set of points, image, set of points, image, set of points, and moving through the image list. In distance-based, there's a lot more points that are being colorized per image, but we do get a more rigorous colorization. So if you wanted to see a quick result, you would probably, you could use time. If you were looking for a deliverable result, you would certainly use the distance option. At the bottom, there's what we're calling a low res mode for distance. So it will use all the points it can see whenever they were taken. But generally in this mode, we thin the data more. There are less points that are chosen at this point. So it's how it works is we really use a line of sight filter, and in high res mode we take all the points. In low res mode we look at the points within voxels, and then if any part of that voxel is hidden in the line of sight, then we remove the whole voxel from the colorization. So this is why it's a slightly, we reduce the amount of points again considerably, although there still is averaging. Again, it's a speed over quality issue. It will give you a better result than timing, but obviously not as good as the full distance method. And lastly on this one, then when colorizing, if we have obviously got points that we can't see, or we've not been able to assign RGB from, then we have the option to either remove those from the final point cloud. If we don't, then at the moment those points are colored black. So you'll see those within the point cloud. But we do have the option, if we can't assign color, then they will be removed from the point cloud. So again, once the color is run, we can load the color point cloud. Connect will automatically in the color modes know it has RGB, and then we're able to see the RGB result. And again, we can still enter bubble view and see the RGB result. So hopefully that's given you a bit more detail on taking capture methods. It's hopefully, we've gone through the workflows slightly more detail, hopefully gives you a better understanding of how we envisage people using them at the moment. That's not to say that they're fully set in stone. We can certainly make changes based on user feedback. Clearly, for the camera, we've not stopped developing. We know that there are certainly a lot of things as a dev team that we want to put in to the first release that we didn't have time to. You noticed on your cameras there are two LEDs, a green and a red. At the moment, that's just constant green. The next iteration of the firmware should hopefully be out in July sometime, not too long. We've altered how that LED works. Power is going to be solid green. Every time it takes an image now, that will flash green to say it's captured an image. And then the other LED, a red LED, will obviously be able to trigger some warning messages, like maybe a problem with the capture, but certainly, if the memory drive is getting full, that will start to flash red to give you a warning. Clearly, again, at the moment, it's really important that we have a copy of the camera cal.json file within the images folder. The next iteration of the firmware, we will manage that as a camera. So every time it creates a new project folder, every time we start a new capture, the firmware will move a copy of the camera file, cal file, into that folder. Slightly more longer term, something we're looking into. I think we're slightly restricted at the moment on memory size. We are looking into ways we can try and improve that without altering, physical dimensions within the camera. We're slightly short on space. For Gen 2 data loggers, which have the Ethernet port in, I think what we really want to do is give the user then the ability to capture imagery, and those images get stored on the Gen 2 data logger via the Ethernet port, and then that will, all the data will be automatically within one folder on the data logger. So the last thing we are aware of, that we've come up with some generic camera settings, for gain, exposure, brightness, color balance, and they're stored safely on the camera. It's whether then what we think would users want then the ability to define their own color map or their own settings file that they could then upload to the camera before a capture, based on their experience. We don't know if that's a good thing, if that will be too complicated for the majority users, maybe some power users. A lot of the dealers are certainly very, very experienced in image taking, so maybe that was something they want. So I think there was going to be a poll running in the chat, just to say, is this, from your experience, would it be useful for end users to have the ability to alter some of these on-camera settings? It's not something we can do on the fly. This is, we'd have to set them, then they would be set for the whole capture. So I think that's generally it for the technical part of the talk. I think we've got time, maybe a few minutes, just while we answer some of the questions we've had in the chat. If there's anything cropped up that I didn't try and cover, clearly you can always write to support@GeoSLAM. Myself, the guys, we're always there, to answer any questions, and arrange calls if needed. So I will look at that. So yeah, we talked about recommended walking speeds. I'd say I generally walk, 1 to 1.5 meters per second. It is slower than I would generally do for a standard horizon. I just certainly, I want the best imagery to, I'm removing blur, even maybe not walking speed, but just to stop any sudden movements of the camera, any twists. That's probably just as important as walking speed. So the calibration, someone asked, do we only have to calibrate on the first install with our backpack or vehicle mount? So really, it's the thing we're trying to calibrate is the offsets from here to here. So as long as this stays attached and fixed, then the calibration, the system calibration is valid. The mounting after that is not a problem. It's really just the difference between the camera and the horizon, and it's keeping that fixed. Is it best to loop around a feature for calibration? Really what we're trying to do is, it's probably best not to loop around, but I generally walk one way in front of it and then come back and walk the other way in front of it rather than go round it. Because then we're getting the same object at different parts of the lens, forward and reverse. So I'll generally say just walk past a feature and then try and come back along a feature. So it's slightly different than a standard horizon walk. Does ZEB Vision have its own mounting accessory to attach with backpack? So I use the standard ZEB locate pole to mount. I say on the back of the camera, we have a standard V mount. There is, not sure if it's out yet. There is a purpose designed backpack, soft backpack coming out, which I don't know, should be out soon, I believe, which will be moving forward the new backpack for all users, but we'll have an integrated telescopic pole for locate and horizon with vision. And yeah, should the camera power up with the SLAM automatically? Yes. Yeah, as soon as essentially what we do is, as soon as we've done our initialization and we start SLAM capture, then we send a trigger signal in the same way we do for ZEB Cam to the camera to start triggering. So yeah, that's that one. Perfect. All right, I think we have run slightly over, so thanks everyone for staying with us. As I say, that we will make this available. If anybody has any questions, please write to support@GeoSLAM. I'll get back to them as soon as I can. The rest of the team are there to answer any questions. All right, I think we will leave it there. Again, thank you for your time this morning. Hopefully it's been useful, giving you a few pointers on ZEB Vision, and you'll enjoy your camera when you get it. Okay, thank you.